What's up guys, welcome to my video. In today's lesson guys, we will be revising science paper 1 2020 examination for general certificate of education ordinary level. Guys, if you are new to this channel, please, you are welcome and feel at home and be relaxed and enjoy watching this video as we revise science paper 1. And if you're already my subscriber, please stay subscribed, as I promised you in the previous video that I am going to upload science paper 1 2020 examination for general certificate of education. And here we are guys, uploading this video, fulfilling our promise and wanting you guys to pass that exam that you are going to write. All right, so please relax and enjoy this lesson. Let's go guys. The question reads, how many significant figures are there in the number 0.050200? Okay, so guys, for you to know the number of significant figures, you need to know that this 0 in front of, or this 0 before 5 is not significant, but these two zeros after 2, they are significant. So the number of significant figures in this number are 1, 2, 3, 4, 5. So this number has 5 significant figures. All right, so let's go to question number 2. Question number 2 reads, a stone of mass 400 grams is lowered into a measuring cylinder containing water. The water level rises from 300 cubic centimeters to 500 cubic centimeters. What is the density of the stone? All right, so we know that density is found by mass over volume, and we are given mass as 400 grams, and we are given a density volume as 500 cubic centimeters minus 300 cubic centimeters, which gives us 200 cubic centimeters. All right, so which means that substituting our values into our equation allows us to obtain this value. So 400 divided by 200, we obtain 2 grams per cubic centimeters. So our answer is D. Then question number 3 reads, the graph below shows the speed of an athlete during a race. The graph below shows the speed of an athlete during a race. Then they say, what is the distance traveled by the athlete? What is the distance traveled by the athlete? So here on our graph, we have the vertical axis representing speed and the horizontal axis representing time. So on such a speed time graph, the area under the graph represents distance. So for us to be able to find the distance traveled by the athlete, we must be able to calculate the area under the graph. So we are going to divide this graph into two shapes. We would divide it into 2 trapezium. The first one starts from here and ends somewhere from here. We'll call it trapezium 1. Then the second one starts from here and ends here, and we call it trapezium 2. So now we know guys that the trapezium has got 2 parallel sides. So for example, trapezium 1 has got these 2 parallel sides. One of the sides is the smallest and one of the side is the largest or longest, and the shortest side is represented by letter A, while the longest side is represented by letter B, and the distance between the 2 parallel line represents the height of the trapezium. So equally for this second trapezium here, so this shortest distance here represents A, while this longest distance here represents B, and the distance between these two parallel sides represents height. So now we know that since we have two trapezium, and we know that trapezium is given by half, open brackets, a plus b, close bracket, height, plus again half, because we have another trapezium here, open brackets, a plus b times height. So we know that from, if this is a, for trapezium, for the first trapezium, a is the distance from this line to this line, which will be 14 minus 4, which will give us 10. Then b is the distance from 0 to this line, which is 14. So here we'll have 10, 14. Then here, the distance here, a here, is from this 0 to this line here, 5. So it is 5. So here we'll have 5. Then b, this also from this same line here to this, which will be 10. So here we'll have 10. Then height here will be from 14 to 16, which will be 2. So substituting, we'll have distance is equal to half, 10 plus 14, close bracket, 5 plus half, open bracket, 5 plus 10, close bracket, 2. So when we add 10 plus 14, we'll get 24, then 5 plus 10 will get 15. Then we are going to multiply 24 times 5, we'll get 160, then 15 times 2 will get 30, 120 here. So again, we are going to multiply half times 120, we'll get 60, and then half times 30 will get 15. Again, we are going to add 60 plus 15, we'll get 75 meters. So our answer is C. Then 4 reads, a 4-kilogram brick is dropped from the top of a building whose height is 30 meters. What is the velocity with which it reaches the ground? So a 4-kilogram brick is dropped from the top of a building whose height is 30 meters. What is the velocity with which it reaches the ground? So here, guys, we have a brick of 4 kilogram, which is being dropped from the top of a building whose height is 30 meters. Then they're asking us to find the velocity with which it reaches the ground. So we know that our velocity should be, or our formula should be equal to, velocity is equal to square root of 2 multiplied by acceleration due to gravity times also height, this one here. And acceleration due to gravity is always given, guys. It is always 10 meters per second squared. So where did we get this equation? We got this equation from the linear equation of uniform accelerated motion, such as this here. However, this equation of linear accelerated motion, they also apply for objects falling under gravity or under gravitational field strength, because they also fall with a certain uniform velocity, or let me say this, they also undergo a uniform motion as well, and they also fall in a straight line. Guys, Chizungu is a problem here, so don't worry. So now, if an object is falling under gravity, here where we usually have acceleration, we replace that acceleration by g, because since an object is falling, it starts falling because there's a force of gravity acting on it. So that force of gravity causes it to accelerate, and that acceleration with which the object falls with as it is dropping, we call it acceleration due to gravity. It's the one we replace here, even here, even here. Now, when choosing which equation to use to solve this question, we looked at data provided here. So here we are provided with what? With 30 meters. When we look at here, yeah, we don't have distance, and here we have time, but here we don't have time in our question. So we said this one cannot work. Then we looked at this one also, which has got a time, but we don't have time. So we said this one also can't work. Then we looked at this one, which has acceleration due to gravity. Yes, because this stone is, or brick is actually dropped, so it is going to fall with an acceleration. So we agreed. Then height, which is 30, we agreed this one can work. All right, however, this one is final velocity, this one is initial velocity, but we should know that the initial velocity of the brick is 0, because that is when it is starting to drop. So the velocity it has as it is starting to drop is 0. So this value is 0. So which leaves us with v squared is equal to 2 h GH. Then we remain with, if we want to remain with v, we square root this side, also we square root this side. So this and this goes, so we remain with v is equal to square root of 2GH. So this is how we came up with that formula, guys. So let us continue now working out this problem. So after having this formula now, what we are going to do is to substitute the values in the equation here. So we are going to say v is equal to, where is equal to square root of 2 times where there's g we put 10 times where there's h we put 30. So this is what we are going to have. 2 times 10 times 30, then multiply these values under the square root, we get 600. When we square root 600, we get 24.49 meters per second, meaning our answer is B. Alternatively, this question can be treated as using the principle of conservation of energy, which says energy cannot be created nor destroyed, but it can be transformed from one form to another. So we take this stone being dropped like here. So if this is the brick, sorry, not the stone, so this is the brick here at some height of 30 meters. All right, so it is at some height of 30 meters from the ground level. So it is raised, or it is at the roof here of the building, the top of the building, and the distance from the top of the building to the ground is 30 meters. So what we should know is that any object raised above the ground possesses some kinetic or some potential energy. All right. So what is potential energy? Potential energy is energy possessed by an object raised above the ground. So since this is raised above the ground at the distance or with the height of 30 meters, it has some potential energy here. All right. However, it doesn't have kinetic energy, because at this point we said its speed is 0, its initial speed is 0. So since its initial speed is 0, it is not moving, it has 0 kinetic energy. Why? Because kinetic energy is defined as the energy possessed by moving object. Now, since this is not moving, it doesn't have kinetic energy, all right? So kinetic energy here is 0. Now, when the stone starts falling, or the brick starts falling, what happens is that the height becomes 0 as it hits the ground. So since the height becomes 0, that means that the potential energy of this brick at ground level B is 0. Now, we stated in the beginning that according to the principle of conservation of energy, energy cannot be created nor destroyed, but it can be transformed from one form to another. So, if we are saying here potential energy is 0 because height is 0, does it make sense? If height is 0, potential energy is 0. Yes, because if you get 0 here, push it there where there is height, and get this m, put mass, and get this g, put 10. You say 4 times 10 times 0. What are you going to get here? 0. So which means at this point B, ground, potential energy is 0. So where has the energy gone? It has been transformed to kinetic energy before it hits the ground. So before this stone hits the ground, somewhere here before it hits the ground, all the potential energy the brick had has been converted into kinetic energy just before it hits the ground. And that is where the question is coming from. They're saying, what is the velocity with which it reaches the ground? So what velocity will it reach with the ground? So since the potential energy now is going to be transformed into kinetic energy, and we know that the formula for kinetic energy contains this velocity, then we will use the principle of conservation of energy. All right, because here potential energy is 0. So we'll use the principle of conservation of energy, which says potential energy at A is the same as kinetic energy at B. Why? Because it is this potential energy which has been transformed into kinetic energy. So we are going to say potential energy at A is equal to kinetic energy at B. Then what now we are going to say here is that we know the formula for potential energy is mgh, and we know the formula for kinetic energy is half mv squared. Then we are going to substitute m for g10 h30. Again, this side m for v we don't know because that's what we need to find. Then after substituting now, m for g10 h30 equals half times m4 times v squared, which we don't know. Now we are going to multiply 4 times 10 times 30, all right, which will give us 1200, and here we'll divide 2 into 4, 2. Then to remain with v on this side alone, we'll divide by 2 and also this side by 2. So when we divide by 2 on both sides, here we'll have 12 divided by 2, which will give us 600. Here 2 divided by 2 will cancel, will remain with v squared. And then we'll square root on both sides. After square rooting on both sides, the square and the square root will go. Here we'll have the square root of 600. The square root of 600 will give us 24.49 meters per second squared, just as we had to calculate using this formula. So 5 reads, the diagram below shows an object moving with a constant velocity when a force E of 30 Newton is applied. The diagram below shows an object moving with a constant velocity when a force E of 30 Newton is applied. So there's this object here moving with constant velocity when this force of 30 Newton here is applied. So now what you should know here is if an object is moving with constant velocity, it means that its acceleration is equal to 0. So if the acceleration of an object is 0, that means that even the force causing it to accelerate is 0, because we know that force, in this case resultant force, is equal to mass times acceleration. So since the object is moving with constant velocity, then the acceleration is 0, because acceleration is the rate of change of velocity. So if velocity is changing, then there is acceleration. But if velocity is not changing, then there is no acceleration. So here now, since there is no acceleration, we'll say acceleration is equal to 0. So if we were to substitute in this equation of force is equal to mass times acceleration, then we say mass times 0, which will give us m times 0, 0, because any number, whether letter, number, if you multiply it with 0, you will get 0. So which means that our force or resultant force is 0. So meaning this force trying to go this way, it is actually 0. Its resultant force will be 0. Now they are saying, what is the value of the opposing force? What will be the value of the opposing force? So for there not to be acceleration here, it means that if this taking it forward, this force taking it forward here is 30, meaning for there to be a resultant force of 0, meaning even the force trying to push it backward is also 0, is also 30. So that this one is going in the positive, so this force here, it's positive 30. This one going in the negative here, it's negative 30, because it's going in the opposite. So if you get positive 30 Newton plus, you add the minus 30 Newton, you get plus 30 Newton minus 30 Newton, which will give you 0. Because here positive, negative, it gives you negative, and you open the brackets. So which means that now 30 minus 30 is 0. Like here, so for the force to be 0 here, this force going this way, meaning this opposing force here is also 30. So our answer is C. All right, so let's rub the trash here. Okay, so let's go to another question. So question 6 reads, a 30 Newton object is placed on a uniform bar that was balanced at its midpoint as shown in the diagram below. So a 60 Newton object is placed on a uniform bar that was balanced at its midpoint as shown in the diagram below. So there's this uniform bar that was balanced at its center or midpoint. When it is balanced, meaning the anti-clockwise moment taking it in this way is equal to the clockwise moment taking it that way. The clockwise rotation must be equal to the anti-clockwise rotation for something to be balanced. So now, after putting this, there's no thinking that this will remain balanced. No, it will not remain balanced, because if it was balanced first at its midpoint, then you place a 30 Newton object, then this one is going to move in the anticlockwise direction, or it will undergo an anticlockwise moment or rotation, as I can demonstrate by this animation. So for example, let's take this as the ground, and also let's take this one as the pivot. Then let's take this one as the uniform bar that was balanced at its midpoint here. Before putting what? Before putting this 60 Newton object, the bar was balanced. Then we are going to see, after putting now here the 60 Newton object, after putting, what will happen? It is going to undergo an anticlockwise moment like this. Good. That's how it is going to move. Then the question now is saying, which of the following will rebalance the beam? Which will rebalance the beam? So the keyword here, rebalance, meaning to balance it again. So they want a force that will rebalance it. So to rebalance it, unless it is pushed back in the clockwise direction. And for you to push back in the clockwise direction, you need to apply the force where on the right side of the pivot. So if this is the left side of the pivot, this is the right side of the pivot, you need to apply the force on the right side to provide the clockwise moment like this. That's when it is going to be balanced. So for this now to be balanced like this, it should mean that the left moment here, the moment on the left side of the pivot, must be equal to the moment on the right side of the pivot. So now, how do we know the moment on the left side? Moment, for this bar to be rebalanced, or for this bar to rebalance, the left moment must equal to the right moment. And we are saying left moment is equal to force times distance. This force here times distance of the force from the pivot. So this distance of the force from the pivot times this force here, it gives us the moment which takes this one to rotate in the anticlockwise moment. So force times distance is equal to 60 Newton times 30 centimeters, which gives us 1,600 Newton centimeters. So this is the force which caused this to go like this, So it is the same force which is needed to be applied on the right, so that this now can rebalance. All right. So since on the left it is 1,800 Newton centimeters, even the right side should contain 1,800 Newton centimeters for it to balance like this. Now, going to our question, which of the following will rebalance the beam? A, 30 Newton force, or A, magnitude of force, 30 magnitude of force, position of the force, 60 centimeters to the left of the pivot. To the left again, if you put it to the left, it will continue moving in the anticlockwise rotation. So this one, no, wrong. Then B, magnitude of the force should be 30. Then position of the force 30 centimeters to the right of the pivot. Yeah, it should be to the right of the pivot. Now, if we multiply 30 Newton times 60 centimeters, will it give us 1,800 Newton centimeters? Yes. So our answer is B. All right, so let's now remove the trash here. All right, so let's continue to the next question, guys. So question 7 reads, a motor is used to pull a 10-kilogram box along a 5-meter long incline to the top of the incline, not decline, incline, as shown in the diagram below. A motor is used to pull a 10-kilogram box along a 5-meter long incline to the top of the incline as shown in the diagram below. So this is the incline plane, and at the top here there's a motor. I'm sure this motor has got a conveyor belt trying to rotate this thing here, and this rope is tied to the motor. So as it is rotating, this rope is winded on the rotor here, and as it is winded on the rotor, this starts moving in that direction until it reaches the top of the incline. All right, and then this incline plane itself here, it has a distance of what? Of 5 meters. Now the question reads, ignoring all friction forces, determine the work done against gravity in pulling the box from the foot of the incline to the top of the incline. Take G as 10 Newton per kilogram. So here they're saying that ignoring all friction forces, determine the work done against gravity. So work done against gravity, to determine work done against gravity, we should first know, guys, we have to know, guys, gravity itself. So gravity acts downward, vertically downwards, like this, towards the center of the earth. So gravity is actually weight of an object, is gravity, and it always acts downward. Now, since this object must do work against gravity, to be against it means to be in opposite. So it should be in opposite again, vertically upward. So to do work against gravity, you should move in opposite direction with gravity, vertically upward, because gravity acts vertically downward because it is a vector quantity. It has direction, and its direction is always pointing downward towards the center of the earth. All right, so this work done by gravity actually is equal to potential energy, because as an object is pulled by gravity downward, that object has got actually potential energy in it. So that potential energy is equal to actually work done against, because you are going in the opposite. It's only that if gravity is positive, then the work done against it must be negative. That is it. So now what we are going to say is that work done against gravity is equal to potential energy, which is equal to mass times acceleration due to gravity times height. And we know that acceleration due to gravity is 10 meters. I mean, yes, 10 meters per second squared, or 10 Newton per kilogram. And we know that m is mass, which is 10. And we know that h is height, which is what? 4, because we are dealing with a vertical motion here. So, which will mean that work will be equal to 10 for mass here, times again 10 for gravity here, times again 4 for height, which will give us what? 400 joules as the work. So our answer is what? C. 8 reads, a girl whose mass is 50 kilogram climbs a ladder of height 8 meters in 10 seconds. What is the power developed by the girl? A girl whose mass is 50 kilogram climbs a ladder of height 8 meters in 10 seconds. What is the power developed by the girl? We know that power is equal to work done divided by time. Now, what will be the work here? This girl does work as she climbs up the ladder. And the work the girl does is in lifting this mass of herself up a ladder a distance of 80 meters. So she does work, and the work which she does is to lift her body going upwards a distance of 8 meters. Because as she will be going upward, she needs to apply some effort to lift that weight of hers. And that that force which she applies must be equal to her weight. And her weight actually is the force which she applies with to go upwards there. All right? So her weight or her force is equal to her weight. And weight is equal to mass times gravity. Now, this will be her force. But we know that work is equal to what? Force times distance. So we know that force now here, we have given it this. This is force. So which will mean that this here now will take mg, then d is the distance. And this distance is height. So it will change as mg height. So meaning the work done, this work is equal to acceleration, is equal to potential energy. So now we are going to say work is equal to potential energy, and it's equal to mgh, as I have demonstrated here. All right? So let's rub this so that we concentrate. So now, what now we are going to do here is to get this as work and substitute it. Where there's W, we put what? mgh as the work. Because W is equal to potential energy is equal to mgh. We put it there. Now that we have this, we can now solve. So we are going to put where there's m, 50 kilogram, where there's g, acceleration due to gravity, which is 10 meters per second, where there's h, we'll put 80 meters. So it will be equal to, power is equal to 50 times 10 times 8 over 10, which is time. Then when we evaluate the entire expression, we get 400 watts as the power. Power is always in watts. All right? So which means that our answer is B. The 9 reads, a machine with a velocity ratio of 6 requires 800 joules of work to raise a load of 60 kilograms through a vertical distance of 1 meter. A machine with a velocity ratio of 6 requires 800 joules of work to raise a load of 60 kilograms through a vertical distance of 1 meter. So here we are told this machine here will require 800 of work to do what? To raise a load of what? Of 60 kilograms through a vertical distance of 1 meter. Then they are saying find the efficiency of the machine. Efficiency has got 2 formulas. Efficiency is equal to mechanical advantage divided by velocity ratio times 100%. Now looking at our question here, we are given velocity ratio of 6. Then can we calculate mechanical advantage? Do we have mechanical advantage? Because mechanical advantage can also be found by load over effort. Do we have load? Yes. The load which we have is 60 kilograms. Do we have the effort? We have the effort in terms of what? Of in terms of energy here or work. So we know that work is equal to force times distance. So this one becomes our effort. So this distance, how are we going to find it? We will try to say velocity ratio is equal to distance moved by the effort over distance moved by the load. Since the distance moved by the effort, velocity ratio is 6. Distance moved by the load is what? 1 meter. Velocity ratio is 6. So we'll try to say, to make distance moved by the effort the subject of the formula, where I'll say distance moved by the effort is equal to velocity ratio times distance moved by the load, which will be velocity ratio 6 times distance moved by the load 1, which will mean that distance moved by the effort is equal to 6. So meaning here we have 6 and here we have what? 800 joules. So if we say 800 joules is equal to 6 times distance moved by the effort. So we'll say divided by 6 divided by 6. So we'll say 2 here. Okay. So we'll have distance is equal to 800 divided by 6. So say 2 here, it will be therefore 2 there, 3. So we'll say 400 divided by 3. All right. So Let's try to do something here. Here we are getting our answer as 133.3. That's what we are getting as our answer. Excuse me. So, which means that this is our distance, or this is our force. So we are going to say then mechanical advantage. Sorry guys, we are just trying. This is not the method I used, but I'm just trying to see. Oh my gosh. This has become permanent. Okay, so we are going to try to say our mechanical advantage now is going to be equal to load, which will be 600 divided by 1.3 or 13.33. So divided by velocity ratio, which doesn't make sense here. So the route taken here is not making sense. So what we are going to do is to continue solving this question. Yes. Yeah, so question 9 reads, Question 9 reads, a machine with a velocity ratio of 6 requires 800 joules of work to raise a load of 60 kilograms through a vertical distance of 1 meter. A machine with a velocity ratio of 6 requires 800 joules of work to raise a load of 60 kilograms through a vertical distance of 1 meter. Find the efficiency of the machine. So when you look at this question here, at first notice you would think this velocity ratio will work, but it will not work because we know efficiency has this formula which says work output divided by work input times 100%. But since we are given this velocity ratio here, it will also create an impression as if we can find efficiency by this formula, mechanical advantage divided by velocity ratio times 100%. So velocity ratio is 6. How about mechanical advantage? Mechanical advantage is found by load over effort. So since we don't have the effort here, we only have energy here. So we are going to use this formula here which says efficiency is equal to work output divided by work input times 100%. So since the question says a machine with a velocity ratio of 6 requires 800 joules of work to raise. So this is the work input that is required to raise a load of what? 60 kilograms. So this will be now the work output. The work which will be done to raise this will be the work output to raise a 60 kilogram through a vertical distance of 1 meter. So we need just to find work output. Work output here is going to be force times distance. And we know that this force here will be calculated by mass times acceleration due to gravity. This one, it will be the force. Why? Because in raising this object up through a distance of what? 1 meter, the work will be doing, the 800 joules will be doing a work against gravity. And that work against gravity, is always 60 times mg. So we'll say force will be mg times d. So work output will be equal to force times distance. Then distance is equal to mg. So work output will be equal to mgd. So replace where there's work output with mgd. Then we are now going to substitute m with 60, g with 10, d with 1 meter. Where is the 10 coming from? Acceleration due to gravity. Then work input with 800 joules. So 60 for 60 kilogram there for mass, 10 for acceleration due to gravity, d for distance, divided by 800 for work input. So when you evaluate this one, you get what? 75. And this means that our answer is D. Question 10 reads, the diagrams below show the length of mercury threads at the ice and steam points. The diagrams below show the length of mercury threads at the ice and steam points. So here is the length of the mercury thread at steam point, and the length is 5 millimeters. And in the second diagram is the length of the mercury thread, which is 15 millimeters at steam point. So let me make you understand this question, which is so summarized. So what happens, or what happened here, is that they got this thermometer, placed it into ice, and the mercury thread was found to be 5 millimeters. So the distance of the mercury thread from the bulb was 5 millimeters. Then they got the same mercury, thermometer, placed it into steam. Steam point, or steam, is actually vapor. All right, vapor. When water is boiling and when it reaches boiling point, it starts producing a lot of vapor or steam. And it is in that steam where they placed this thermometer. And the mercury thread was found to be 15 millimeters above from the bulb. So then they say, what will be the temperature if the length of the mercury thread is 25 millimeters? So this question, for you to be able to answer this question, you must first understand what is happening here. You need to spin your brain a little bit. So this is actually an experiment that is used to calibrate a thermometer. So it is easy to calibrate a thermometer when you know two temperatures or 2 points of a thermometer with known temperatures. For example, ice at ice point, or the temperature of ice, is 0 degrees Celsius. So when you dip a thermometer into ice and the mercury thread is found to rise by 15, at that mark where the mercury thread ends, at that mark, it is actually at 0 degrees Celsius, because ice is at 0 degrees Celsius, melts at ice at 0 degrees Celsius. So ice point is the point at which ice begins to melt, and ice begins to melt at 0 degrees Celsius. So when they placed there, they discovered that this is how the mercury thread had to rise, and at that temperature is 0 degrees Celsius. And when mercury, or the thermometer, is placed in steam again, steam point is the temperature at which water now starts evaporating into steam, and that temperature at which water starts turning into steam is 100 degrees Celsius. So in short, here there will be just a production of this thermometer here with 2 points. One point will be 0 degrees Celsius. Another point will be 100 degrees Celsius. So after you know these 2 points here, it's just to find the length between 0 and 100. So here, if you check here, the length between 0 here and 100, this length can be found by just subtracting 5 from 15, which will show you that this is actually 10. All right, so this is actually 10 millimeters. So if this is 10 millimeters, the way we do it, if we want to calibrate this thermometer, It is just to get now 100 divided by 10, which will give you 10. So you make 10 equal parts here. One, two, three, 4, 5, 6, 7, 8, 9, 10. Then each one of them, you give them 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. So if this one 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. By doing so, you could have, or you would have calibrated a thermometer. That's how it works. Now, this situation here provided is a little bit complicated. It's a little bit complicated. Here, what they're saying now is that this thermometer again is placed again in what? In a 25 millimeters. So they want you now to know what temperature will be there. So what will help you is this information given. In ice point, it raises by 5 millimeters. In steam point, it raises by 15 millimeters. So you know steam is at 100. Then you know ice point is at 0 degrees Celsius. Then what is it going to be at 25 millimeters? So there's a formula we use where we say Tu, which is an unknown temperature, is given by 100 open bracket LU, which is just length of the mercury thread at an unknown temperature. In this case, at this known temperature, what? 25. So the length of the mercury thread at an unknown temperature is what? 25. Minus length of the mercury thread at ice point, which is 5 as the length of the mercury thread, divided by length of the mercury thread at 100 degrees Celsius, which is at steam. Steam it is at 100. So the length of the mercury thread is 15 minus length of the mercury thread at ice point, which is 5. So substituting these, okay, this is saying temperature at ice point is 0 degrees, temperature at steam point is 100 degrees Celsius. I already explained this. So substituting these values, we have 100 open brackets 25 minus 5 divided by 15 minus 5, then 25 minus 5, 20, then 15 minus 5, 10, then 100 times 20, which is 2000, 2000 divided by 10, which is 200. So meaning that an unknown temperature is 200 degrees Celsius. Coming to our question here, there's no answer here corresponding to our answer. That means there was an error with ECZ here. Now, if you want to understand it better, you can just put the way I had to draw that other figure for a thermometer, where you say, you know 2 points, you say, from 0 to 100 degrees Celsius, the length here of the mercury thread is 10 degrees Celsius. Now here they've placed this one into there, so you have a different situation here where you have now so the distance from here to there. Now they've told you it's 25 millimeters. Now you need to know just the distance from ice point, which is a 0, to that point temperature unknown. So you just say from this point to 0 it is 5. So say 25 minus 5, you get 20. So here you have 20. So you are going to say now that this is the same situation I had to demonstrate. From here to there is 10. All right. So now what you are going to say is that if from 0 to steam point, which is 100, from 0 to 100, it is rising by what? By 10 millimeters. So say from 10, or a rise by 10 millimeters gives you 100. What about this rise now by 20? You say a rise by 20 will give us x. So you cross multiply, you say 10 millimeters times x, you get 10 millimeters x. Then 20 millimeters times 100 degrees Celsius, you get 2000 millimeters degrees Celsius. So you divide this side by 10, also by 10 millimeters. 10 millimeters will remain with x as what? 200 degrees Celsius, as found by the previous situation. So here it simply means that the Ecz guys did not provide the correct option here. So let's go to the next question. The next question reads, the diagram below shows a cylinder with a gas trapped inside at a constant temperature. So the diagram below shows a cylinder with a gas trapped inside at a constant temperature. The length of the gas column is 5 centimeters and the pressure of the gas is 20 pascals. So this is the cylinder, and inside the cylinder is a piston, which is a movable part like a pump. All right. Then here they're saying if the piston is pushed a distance of 30 centimeters inside, what is the new pressure of the gas? So for you to be able to answer this question, you must know where it is coming from. Gas laws. So it is coming from gas laws. So we need to revisit now gas laws here, where we are going to use this short way of memorizing gas laws. B for beautiful, C for cute, G for girls, T for 10, P for province, then V, Vince. So I read this as beautiful, cute girls of 10 provinces. B for boys' law at constant temperature. C for Charles' law at constant pressure. G for Gauss' law at constant volume. So what does Bohr's law states? Bohr's law states that for a fixed mass of a gas at constant temperature, pressure is direct inversely proportional to volume. Then Charles' law states that for a fixed mass of a gas at constant pressure, volume is directly proportional to temperature. Then Gauss' law states that for a fixed mass of a gas at constant volume, pressure is directly proportional to temperature. So these are the gas laws. Now looking at the question here, the diagram below shows a cylinder with a gas trapped inside at a constant temperature. So the one which deals with constant temperature is Boyle's law. So now here we need to apply Boyle's law to answer this question. So it wasn't as straight like that. So now what we are going to say is that Boyle's law can be written as PV is equal to K, and Charles' law can be written as V over T equals K. Then Gauss' law can be written as P over T equals K. So this can be written as P1 V1 is equal to P2 V2. Because since it is constant, it means the multiplication of P times V at one point must be equal to the multiplication of P and V at another point. For example, the multiplication of pressure times this distance here at this point here must be equal to the multiplication of what? Of the same. So if this situation here as it is, pressure is 1, volume is what? V1. Then the push, if the piston is pushed a distance of 30 centimeters inside, then the piston moves 30 centimeters. It comes like here. This piston moves. It reaches where? Here. Then here we'll have different pressure which we'll call 2, and we'll have also different volume which we'll call 2. But the fact is that if you multiply pressure times volume here, it should be equal to pressure times volume again here. So before pressure times volume, before you compressed, is equal to pressure times volume after you compress. So which means that that's what this means. Also here it also means the same. V1 over T1 is equal to V2 over T2. Here also it also means the same. P1 over T1 is equal to P2 over T2. And the combined gas law is P1 V1 is equal to P1 V1 over T1 is equal to P2 V2 over T2. But here, since as we are dealing with constant temperature, meaning we are dealing with Boyle's law. So to answer this question where they are saying if the piston is pushed a distance of 30 centimeters inside, what is the new pressure of the gas? If the piston is pushed a distance of 30 centimeters inside, what is the new pressure of the gas? So if the piston is pushed 30, for example, up to here, then what will mean is that the length here, we'll consider the length here, which will be 20. Alright? 50 minus 30 will have 20 centimeters. So now we are going to substitute in our equation where we are going to say P2 is equal to 20 which is our pressure here 20 times 50, which is our V1, then over V2, which will be 20. Then when we evaluate this one, we are going to get what? Instead of this value here, it is an error, we'll get 50. All right. So our answer is D. All right. So 12 reads, which of the following correctly gives the properties of a sound wave? Which of the following correctly gives the properties of a sound wave? A, nature, longitudinal, yes, sound wave is longitudinal. Then speed in air, 340 meters per second. That's true. The speed of sound in air is 340 meters per second. So the answer should be A. Here where they are saying nature of sound wave longitudinal, yes, speed in air 3.0 times 10 to the power 8 meters per second. This is for light. Here see where they are saying nature transverse wave is a lie. Here again where they are saying nature transverse, these are lies. So 13 reads, the diagram below shows the movement of a ray of light from air to plastic. The diagram below shows the movement of a ray of light from air to plastic. Right? So there's this ray here moving from air to plastic. Then they are saying which ratio is the refractive index of air? We know that refractive index is equal to sine of the angle of incidence divided by sine of the angle of refraction. And the angle of incidence, it's the angle between the incident ray. This is the incident ray and this is the normal. So this angle between here, it's called the angle of incidence. Then the angle of refraction, it's the angle between this refracted ray here, the angle between this refracted ray and the normal here, this angle here. This angle is the angle of refraction. So which means that our answer will continue as refractive index is equal to sine. Now substitute. Angle of incidence is what? 45 degrees divided by sine angle of refraction, which is 30 degrees. So we'll check from our option which one matches our answer. It is B. So the answer is B. 13. All right. 14 reads, the diagram below shows the main sections of the electromagnetic spectrum in order of increasing frequency. So the diagram below shows the main sections of the electromagnetic spectrum in order of increasing frequency. So we have radio waves, here nothing, then we have Q, light, nothing, then gamma rays. Then they're saying, which of the following is an application used by Q? Which of the following is an application used by Q? This Q here. So we need to identify Q by using a short way of remembering these waves, where we say R for roast. We say roast maize is very unusual Christmas gift. So as you can see, R stands for radio waves, M stands for microwaves, E stands for infrared, then VERY stands for visible light, then AN stands for ultraviolet, then X stands for X-ray. So meaning here we have radio waves, microwaves, infrared, visible light, ultraviolet, X-ray, gamma rays, because G is for gamma rays. So here we have identified Q as infrared. So what is an application of infrared provided down here? A, an application, it is used in what? Sterilization, no. Satellite television, no. Killing cancerous cells, no. Television remote control, yes. So our answer is D. 15 reads, the diagram below shows a coil in a magnetic field. The diagram below shows a coil in a magnetic field connected to a DC supply. So we have this coil here in a magnetic field because we have a magnet with north pole here and another magnet with south pole here. And this coil here, it is connected to a source of DC supply. Then the question reads, as the current I flows in the coil, this is the current I flows in the coil, in which direction will the coil rotate and what must be connected to parts R and T? So in which direction will the coil rotate? There are two directions here. Is it clockwise or anti-clockwise? And again, they are saying what must be connected to parts R and T here. What must be connected? So here I'm going to go through with you to revisit some theories about the AC generator, and also about the DC motor. This is the DC motor. So one of the differences here is that when you look at the AC generator here, it is connected, the terminals here are connected to the ammeter. And what is the function of an ammeter is to measure current. Where is this current coming from? The generator. How is this current generated? By rotating the what? The coil. So a coil is rotated by some other means, either using another engine, like a two-piston engine, which uses fuel, or maybe using another motor using solar. I don't know. Whatever thing they can use, provided this coil is rotated, then here to produce some current that will be measured by what? By an ammeter. Then the other thing that you should notice is that it has the slip rings here as its commutator or connectors to the coil. Slip meaning they are not split. Then, when you come to the DC generator, what you are seeing here at the terminals here, outside here, is the source of power here, DC. So meaning that this DC generator or DC motor, it is using current for it to start rotating, and they've put an arrow there to show the direction of rotation, that it is rotating in the clockwise direction. And here, these terminals here of the coil are connected to this ring here called the carbon brush. And these rings here, actually we call them split because they're split in between. So we call them split. Split rings. Split, not P here. So split rings. Then you should also know that for you to know the direction of rotation like this, here you use what we call the left hand rule. You use the left hand rule where the thumb here points in the direction of motion or rotation. Then the first finger here points in the direction of field. Then the second finger here points in the direction of current. So you use the left hand rule when dealing with the motor, DC motor. So what you can do here is that you bring your hand here in this diagram and you position your finger here. This finger should point in the direction of field from north to south. Then this finger here should point here in the direction of what? Of current here. Then what will happen? This will point what? Upward. So since this will point upward, that will mean that this thing will rotate like this in the anti-clockwise direction. All right? So since it will rotate in the anti-clockwise direction, then where should it be connected? This should be connected to what? The split ring. This is where they will be connected to the split ring, which will be connected to some source of, this side it will be positive, this side it will be negative. Because sometimes they can ask you to complete the diagram. So this is how it can be half. So this will be the split ring commutator. So now we know now. So this one we use what? The right hand rule to know the direction of current and motion. That's what we use. So here now, looking at the answers provided here, so according to the direction of rotation of the coil, it should be anti-clockwise. Then part connected to R and T, it should be what? It should be split ring commutator. So the answer should be C. Then 16 reads, the diagram below illustrates what happens when metal balls H and J and K suspended by insulating threads are brought closer to each other. The diagram below illustrates what happens when metal balls H, J, and K suspended by insulating threads are brought closer to each other. So these are metal balls H, J, K, J. Then the question says, if the charge on H is positive, if the charge on H here is positive, what charges are on both J and K? If the charge on H is positive, what charges are on both J and K? So for you to be able to answer this question, you need to analyze it critically. So you need to look at the strings here. So these strings here, or the threads here, since they are tilted inwards, it means that these actually balls are coming closer to each other. The distance here between these is not wide. It is what? Narrow, as compared to this distance here. So the distance here is narrow. It means there is what? Attraction here between H and J. Now, since H is positive, what charge will be J here? Now, according to the law of static electricity, it says unlike charges attract. So for there to be attraction here, it means the charges here are unlike, meaning they are not the same. And in nature, we only have two types of charges, positive and negative. So here, if the charges are not the same and this is positive, this means J is negative. Then when we go to this second diagram here, what we are seeing is these threads here, they are not moving inward but outward. And then the distance between K and J is wide. So it shows that there's a repulsion here. These are repelling each other. Now, since they are repelling each other, and we know that J is what? Negative, because here J is negative, here it will also be negative here. Now, since J is negative, according to the law of electrostatic, it means that like charges are the ones that repel. Like charges repel. So for there to be repulsion here, it means the charges are like. So meaning K also has got negative here. So since K negative, J negative, so when we come here, K negative, J negative, our answer is B. Let's continue. 17 reads, two resistors are connected in a circuit as shown in the diagram below. Two resistors are connected in a circuit as shown in the diagram below. So we have this resistor here, which we can call resistor 1. This resistor here, which we can call resistor 2. Then we have a source of voltage here, which is the cell and the switch. Then we know that if current is coming from here, we can call this current I. When it reaches the junction, current in parallel circuit divides. So there will be some current which will go in resistor 1. This current will call it I1. Then there will be some current which will go in resistor 2, which will call current what? Current 2. Okay? All right. Then the question says, which labeled ammeter has the highest current reading? Which labeled ammeter has the highest current reading? So we have ammeter W, ammeter Y, ammeter X, and ammeter Z. Now, which one of these, Z, X, W, and Y and W, will have the highest current reading? What we should know is that resistor W, current W and current Y, they are in series. So since they are in series, they are reading the same current. So current 2 is this, it passes through ammeter A, ammeter W. It's the same current which passes through ammeter Y. So this current I2, which passes like this, comes back here, I2, and this one also comes back here as I1. And when they reach again here, they join. And here, what will pass here, going this way, it will be again current I. So which means that I current I is equal to what? I1 plus I2. Now, ammeter Z is reading I. Current I is the one now which passes here. All right? So which means ammeter Z is the one which will read the highest current reading. All right? So here what we said that ammeter Y will read the same current as ammeter W. Then we also said that current in the X plus current in the W or Y is equal to current in the Z, which means when you add these two currents are the one that will go here. So meaning this one will read the highest. So our answer is D. Then 18 reads, what is the cost of running a 100-watt lamp for 30 minutes if electrical energy costs 10 kwacha per unit? What is the cost of running a 100-watt lamp for 30 minutes if electrical energy costs 10 kwacha per unit? So first of all, you need to know the price, the cost, because they are saying what is the cost. So cost is given by energy used times unit price or price per unit of energy. And then you should know that energy is equal to power times time. So meaning where there is energy here, replace with PT. So cost now is going to be PT times unit price. But you know that the power is always measured in kilowatts when when it concerns usage of electrical energy. Where usage of electrical energy is concerned, power is measured in kilowatts, and also time is measured in hours. So meaning since we are given power as 100 watts, so you must convert it in kilowatts by dividing by 1000, which will give you 0.1. And also this time you are given is in minutes, so you must convert it in hours by dividing by 60, which will give you 0.5. So you substitute here P 0.1, T 0.5, then unit price it is 10 per unit. So you substitute 0.1 times 0.5 times 10, which will give you as cost 0.5 kwacha, which will mean that the answer is what? B. Then 19 reads, the following can be used in detecting alpha particles, beta particles, and gamma rays. The following can be used in detecting alpha particles, beta particles, and gamma rays. So we have the photographic film, the diffusion cloud chamber, the gigamolar tube, the spark counter. Then they are saying which of the above cannot be used to detect beta particles and gamma rays. So here it is just the matter of remembering. So the answer here is 4. Spark counter cannot be used to detect beta particles and gamma rays because these have less ionization power to bring about ionization of particles that can create a spark that can be read as an indication of the presence of some beta radiation or gamma radiation. Then question 20 reads, A radioactive source which has a half-life of 1 hour gives a count rate of 100 counts per second at the start of an experiment and 25 counts per second at the end. How long in hours did the experiment take? So they are saying a radioactive source which has a half-life of 1 hour gives a count rate of 100 counts per second at the start of an experiment and 25 counts per second at the end. How long in hours did the experiment take? So what you should understand here are these terms like half-life. Half-life is the time taken for half of the original amount of a radioactive material to decay. For example, if I have a radioactive material weighing 10 kilogram, and if it has the half-life of 2 hours, it means that 10 kilogram, after 2 hours, it must half. So the half of 10 kilogram will be what? 5 kilogram. Meaning after 2 hours, which is the half-life, that kilogram must half. 10 must half to 5 kilogram. Again, after the same 2 hours, which is the half-life, again that remaining 5 kilogram must half into what? Into 2.5 kilogram. Again, after 2 hours, that 2.5 kilogram must half. So it must continue halving until there's none left in terms of the radioactive material. Now, that process is what we call radioactivity, all right? The breaking down of a radioactive material to emit radiation in form of alpha particle, beta particle, and gamma rays. That is what radioactive is all about. Now here they are saying a radioactive source which has a half-life of 1 hour, meaning after 1 hour it must half its amount of this. Now they are saying 1 hour gives a count rate of 100 counts per second at the start of an experiment. It means that this count is the amount they have of this radioactive source at the beginning of the experiment, which means that after 1 hour, this continues halving. So as they are beginning at the start of the experiment, they have this. Now they are saying, and 25 counts per second at the end. Now they are saying after the experiment, they discover that this now has gone to 25 counts per minute. Then they are saying how long in hours did the experiment take? So the time the experiment took is the same as the time it took for this count to decrease to what? To 25 counts per second. So we use now half-life here. So it means after 1 hour, this must half. Again, after 1 hour, it must half until it reaches where? Here. So we'll take this approach. We'll say we have this as our amount at the beginning. After 1 hour, this must have to what? To 50 counts per minute. Again, after 1 hour, this again must have to what? To 25 counts per minute, which is what was recorded at the end of the experiment. Then the question now is saying, how long in hours did the experiment take? So now they want the total time from the beginning to the end. the total time from here, which it took to move now from here up to here. So you use this time. So you have this time to move from here to here, plus this time to move from here. So you add here total, which will be 1 hour plus 1 hour, which will be 2 hours. So your answer is 2 hours, which will be B. So you can take another approach here, another formula here, where we say 2 to power n is equal to A subscript O divided by A, where this A subscript O stands for original count, or initial count, the count at the beginning. Then A stands for remaining count, like in this case 25 count. So this original 100 in this case. Then N here stands for number of decays. How many times does it take for that original amount to go to remaining? So the number of decay, times of decay, or times of half-life, if you want, number of half-lives, yes, which has happened for this to decay to that. So you can now substitute. Where there's original amount count, you put 100. Where there's remaining count, you put 25, this one. Then you divide. 100 divided by 25, you get 4. Here now you apply the laws of indices. Because according to this is saying 2 to power n is equal to 4, meaning what is on this side, left side of the equation, is equal to what is on the right side of the equation. Now, since this number can also be written in form of a power, so you have to write this number in form of a power such that the base on the right side of the equation must equal to the base on the left side of the equation. Then ask yourself, which number here should I put 2? Since if the base here is 2, here also the base is 2. Now, you need to put a power to 2, such that 2 to that power must give you back the 4. All right? So the power will be what? 2. So here you say n 2 to power n is equal to 2 to power 2, because 2 to power 2, which means 2 times 2, must give you 4. So what now you are going to do here is to now equate also the powers. So since the bases are equal to 2, it means also the powers are equal for this expression here to hold. For this equal sign to hold, to say what is on this side is equal to what is on this side, since the bases are equal, meaning even the powers are equal, or meaning where there's n here, there's also 2, which means that n is equal to 2. Now we find n. Where do we use it? We use it in this formula now, where we say t, which is now the total time taken, is equal to number of half-lives that has taken place times half-life, or number of decay. So number of decay is now 2. So we'll replace here 2. Half-life is 1 hour. We will put 1 hour here. So we'll have total time is equal to 2 times 1. 2 times 1 gives us what? 2 hours. So our answer still remains B. So you can either use this or use this other method. The choice is yours, depending on which one you find to be simple and the fastest. So now we can go now to section B. So at this point, guys, if you are finding value in this video, please give me a like to encourage me to continue doing this kind of stuff that I'm doing. Or if there's something that I haven't done well, give me a thumbs down. And also, when you give me a thumbs down, also comment in the comment section there the point you want me to improve in my lessons. All right, that's how YouTube works. All right, so if you haven't subscribed, guys, consider subscribing, because on this channel we'll be discussing a lot of issues that will also be concerning school leavers. How should school leavers behave? Because you grade 12s that will be writing very soon, you'll become school leavers. So how should you conduct yourselves up to that point when the results are out, and what should you do? So those are the things that will also be sharing with you, the young ones, to guide you on your path to that point. All right, so please remain subscribed. All right, more things are coming on this channel. So now we are on section B, 45 marks. Answer all questions in this section. Write your answers in the spaces provided on the question paper. So here, you always write the answers on the spaces provided, like this one here. So here, B1 reads, an object of mass 75 kilogram on Earth is taken to the moon, where the gravitational field strength is 1.6 Newton per kilogram. So an object of mass 75 kg is taken. An object of mass 75 kilogram on Earth is taken to the moon, where the gravitational field strength is 1.6 Newton per kilogram. Then A, they are saying, what is the mass of the object on the moon? So what will be the mass? It will still be 75, don't worry, because mass is constant at every or in every place of the universe. That's how it is. So it is still 75. Then B, they are saying, calculate the mass of the object on the moon. Calculate the weight of the object on the moon. So you know that weight must be calculated by what? Mass times acceleration due to gravity. And this object of yours, they are saying an object of mass 75 kilogram on Earth is taken to the moon, where the gravitational field strength is 1.6 Newton per kilogram. So to find weight here, you say weight is equal to mass times acceleration due to gravity or gravitational field strength. And the mass is 75, and the gravity on the moon is 1.6. So you put 1.6 here. Don't make a mistake by putting 10, because they are saying calculate the weight of the object on the moon. So you get the acceleration due to gravity of the moon, which is 1.6. You put the 75. So say 75 times 1.6, which will give you 120 Newton as weight. Weight is measured in Newton because it's a force. So you put your answer there. Forgetting units in science will make you lose marks. Then C says, give two differences between mass and weight. There are many differences that you can give. So I decided just to give these. I gave one, mass is constant everywhere in the universe, while weight changes from place to place in the universe. Then another one I gave is that mass is measured in kilograms, while weight is measured in newtons. So you could also give your own to say mass is the amount of matter contained in an object, while weight is the pull of gravity on an object of mass. You could have also said mass is a scalar quantity, while weight is a vector quantity. You could have also said mass is measured using a beam balance, while weight is measured using a spring balance. All right, so let's go to B2, which reads a bullet of mass 50 gram moving with an initial speed of 500 meters per second penetrates a wall and comes to rest in 0.2 seconds. So a bullet of mass 50 grams moving with an initial speed of 500 meters per second penetrates a wall and comes to rest in 0.2 seconds. Then A, calculate the deceleration of the bullet over the 0.2 seconds. So we will use the same formula for acceleration to calculate the deceleration. So acceleration is equal to final velocity minus initial velocity over or divided by time. So now a bullet of mass 50 gram moving with an initial velocity of 500. So initial here will be 500 meters per second, penetrates a wall and comes to rest. So it comes to rest, meaning it comes to a stop. So there at the stop where it comes to the stop or to rest, its final velocity is 0 because it will rest in what? 0.2 seconds, meaning time is 0.2 seconds. So you substitute 0 minus 500 over 0.2, which will give you, I never divided there, okay, which will give you now 0, or which will give you negative 2,500 meters per second squared. So deceleration is always negative. So it will be negative 2,500 meters per second. That's the deceleration. Then B says determine the retarding force acting on the bullet. Determine the retarding force acting on the bullet. So retarding force, it is the force that brings something to a stop. So it is a force that brings an object to a stop. So retarding force is opposite force and it is negative, but the formula is just the same. So retarding force is equal to mass times the acceleration. But this acceleration here must be deceleration. So we know the mass was 50 grams. So 50 grams can't be used. All right, 50 grams there can't be used because grams are not the SI units for mass. SI unit for mass is kilogram. So we divide 50 by 1000, which will give us 0.05. Then the acceleration due to gravity, the acceleration which was a deceleration, it will be the same, negative 2,500. So same, this is the same mass here, 50 grams. Or 50 grams, yes, which when you divide by 1000 will give us 0.05 times now the deceleration, because when you are calculating retardation, don't use the positive acceleration, use deceleration. So when we multiply this, we will get negative 125 Newton, which is our deceleration. Put it like that, not forgetting the units. All right, then we will go to B3, which reads figure B3.1 below shows a pulley systems. Figure B3.1 below shows a pulley systems. So this is a pulley with the two grooves or pulleys themselves and a load here of 120 Newton. Then here they are saying state the velocity ratio of the pulley shown in figure B3.1 above. So you state, it is just to say it. If it is a number, you state the number here. That's what they want. State the velocity ratio of the pulley shown in figure B 3.1 above. So velocity ratio is found by counting the number of strings connecting this upper pulley to the lower pulley. So here there's this string 1 and there's this string here 2. So there are 2 strings. So velocity ratio is equal to the number of strings connecting the lower pulley to the upper pulley. So there will be 1, 2. So velocity ratio is 2. Then B reads, if the efficiency of the pulley is 75%, what is its mechanical advantage? If the efficiency of the pulley is 75%, what is its mechanical advantage? We know the formula here, that efficiency is equal to mechanical advantage over velocity ratio times 100%. So since they are saying what is its mechanical advantage, we will make mechanical advantage the subject of the formula as follows. So mechanical advantage will be given by efficiency times velocity ratio divided by 100%. All right? Then we are going to substitute. Efficiency is 75%. Velocity ratio, we found it as 2. So same 75% times 2 divided by 100%, which will give us as mechanical advantage as 1.5. So our mechanical advantage is 1.5. All right? So C says if the load is 120 Newton, what is the size of the effort? So if the load is 120 Newton, what is the size of the effort? So here we'll use mechanical advantage. Mechanical advantage is equal to load over effort. That's what the mechanical advantage also is. And we are told the load is 120 and the mechanical advantage is 1.5. Then they are saying what is the size of the effort. So we'll make effort the subject of the formula here. Effort will be equal to load divided by mechanical advantage. And the load is 120, mechanical advantage is 1.5. So 120 divided by 1.5, which will give us effort as 80 Newton, because effort is a force, so it will be in Newton as these, without forgetting the units. All right, then we'll go to D. Says, what work is done by the effort if the load is lifted 0.5 meters? What work is done by the effort if the load is lifted 0.5 meters? So this question was a little bit tricky, but what helped me to answer this question was remembering velocity ratio. We know that, so this is the question here. So effort is 80. So we need to know the work done by this effort of 80 Newton. So work is equal to distance times, force times distance. So before we know the distance now, first of all, we should find the distance moved by the effort. Then we multiply effort, which is the force, times that distance to find the work. So here, what helped me is to remember that velocity ratio is given by distance moved by the effort divided by distance moved by the load. So, which will mean that since distance moved by the load is 0.5 and the velocity ratio was found to be 2. So make distance moved by the effort the subject of the formula. So we'll say distance moved by the effort is equal to velocity ratio times distance moved by the load, and we'll substitute 2 times 0.5 distance moved by the load, which will give us distance moved by the effort as 1 meter. So if this is 1 meter, then we'll know now work done by the effort is equal to force times distance. And this effort is this force here. So we'll put here 80 times 1, which will give us 80 joules as the work. So this really has to make sense. So let's go to B. B4 says waves travel at a speed of 30 meters per second through a medium. Waves travel at a speed of 30 meters per second through a medium. If 10 waves pass through a point per second, if 10 waves pass through a point per second, A, calculate the 1 frequency of the wave. So for us to be able to calculate frequency of the wave, we should remember first the definition of frequency. Frequency is the number of complete waves made in a second. The number of complete waves made in the second, in 1 second, or the number of complete waves produced per second. That's what frequency is. So which means by formula, it means frequency is equal to n, the number of complete waves, divided by time, because the seconds is time. Then if we go in our question here, they are saying if 10 waves, so meaning 10 waves, meaning that 10 complete waves here pass through a point per second. So there are 10 waves that are passing a point per second. So time here is 1 second. So we'll say number of waves, that 10 waves. So say frequency is equal to 10 over 1, which will give us 10 Hz. So our frequency is 10 Hz. Alternatively, you can approach this question using period. You know that period is the time taken to make one complete wave or one complete oscillation. The time taken to make a complete oscillation. So now we'll say, okay, period is equal to time taken to make a complete oscillation or to make complete waves. So here we have 10 waves. The time taken to make complete 10 waves is 1. So you say period is 1 over 10, then which when you divide 1 by 10, you get 0.1 seconds. But you also know that period is equal to 1 over frequency. So since you know period, you want frequency, make frequency the subject of the formula, which will be frequency is equal to 1 over period. So period is 0.5. So get 1 divided by 0.1, which will give you 10 Hz. All right? So frequency again is still 10 Hz. Then 2 says you should calculate wavelength. Yeah. Calculate the frequency of the wave. Then 2 here, which I've brought here, calculate wavelength of the wave. So we know the formula which connects speed and wavelength and the frequency. So we say speed is equal to wavelength times frequency. So since we want wavelength, we'll make wavelength the subject of the formula. Okay, so here our formula for calculating wavelength is velocity is equal to wavelength times frequency. Then we'll make wavelength, the subject of the formula, which will give us velocity divided by frequency. Sorry, here we are supposed to have frequency here, guys. So here frequency, then we are going to substitute, since we are told speed is this and frequency we found it in the previous question as 10. So substitute 30 divided by 10, which will give us 3, which means that our wavelength will be 3 meters, and we'll record it as 3 meters as such. Then B says, what does loudness of a sound depend on? What does loudness of a sound depend on? So loudness of sound depend on amplitude. The higher the amplitude, the louder the sound. And the lower the amplitude, the softer the sound. So loudness depends on the amplitude of the wave. All right, let's continue. B5 reads, figure B5.1 below shows a ray of light moving from one medium to another. So this is a ray of light moving from one medium to another, medium A, medium B. A says, find the angle of refraction. Find the angle of refraction. So what we know here is that the angle, where are we? We are here. What we know here is that the angle of refraction is the angle between the normal and the refracted ray. So this angle here is what we call the angle of refraction. Now, what you should know is that the angle between the boundary and the normal, this angle between the boundary and the normal, it is always 90 degrees. If you don't know this, then you haven't been doing anything at school. Sorry to say that. So which means also this side, it is also 90. So you also know that this side also is 90. Because angles on a straight line add up to 180. So if this is 90, this is also 90. Now, the situation which is here is that they just want you to find this angle here, the angle of refraction here. So since you know that the whole of this one is 90, but you are just given this part, so you just say 90 minus 65. So 90 minus 65, you will get what? 25 degrees. So your angle of refraction is 25 degrees. There. So let's move. Then they are saying calculate the refractive index of medium B. Refractive index is given by this formula. Refractive index is equal to sine of the angle of incidence divided by sine of the angle of refraction. And we know that the angle of incidence here is an angle between the incident ray and the normal, which is 50, and the angle of refraction is the angle we found, which was 25 degrees. So we'll substitute refractive index is equal to sine of the angle of incidence, which is 50 degrees, divided by sine of the angle of refraction, which is 25 degrees. Then when you calculate these, you punch on your calculator, open bracket, sine 50 degrees, close bracket, then you punch divided by, you say open bracket, sine 25 degrees, you say close bracket, you punch equals. It will give you refractive index equals 1.81, which you can write as 1.81. 8 as your answer. Then C, they are saying which of the two media is denser than the other. So we have medium A and medium B. Which one is denser? Of course, it is medium B. The reason being is that when a ray of light is traveling from a less dense medium to a more dense medium, it refracts towards the normal. And this one has refracted towards the normal, which means medium B is more dense. If it was less dense, this ray should have, after reaching this side, it should have gone that way, refracted away from the normal. Then let's go to another question, B6. B6 reads, figure B6.1 shows an object O placed in front of a thin converging lens of focal point F. Figure B6.1 shows an object O placed in front of a thin converging lens of focal point F. So this is a thin converging lens represented by this line with an arrow. Then we have this also arrow here representing an object. And then we have this line passing through the center of the lens called the principal axis. Then we have this F here called the distance from here, the center of the lens to this F. It is called the focal point or focal length, which is the same as here because it's the same on the opposite sides. Then here they are saying A, complete the ray diagram to locate the position of the image formed by the converging lens. Complete the ray diagram to locate the position of the image formed by the converging lens. So here we need to know the image formed by completing this diagram by drawing some rays. So the rule is that if you want to know where the image will be formed of this object, you draw one ray, a straight ray from the top of this image that should pass through the center of the lens. So you draw from the top through the center and put an arrow there to show that the ray is traveling from an object. Then the second ray is drawn from the top of the you draw a line from the top parallel to the principal axis up to where? To the lens. So this is the line parallel to the principal axis up to the lens, and you also put an arrow on it. Then here now you draw another one from here. You connect from where this parallel ray ends from the lens. You draw now a line that should pass through the first focal point there. So you draw it like that and you put an arrow there. Now where these two rays crosses each other or intersect each other, that's where the image is. So you draw the image from the principal axis to where the line crosses like that. So this is the image. So here, this is what you needed to do, or you are needed to do if such a question is to come. Then let's go to another question. Question B says, state the characteristics of the image formed. So let's bring the image here. So what are the characteristics of this image formed? Number one, we can just observe that since the object is upright, the image is upside down. So you can say the image is upside down or inverted. All right. So one characteristic is that the image is upside down. Again, such an image which is on the opposite side of the object is said to be real. So this image, again, it is real. Again, when you look at the size of the image and the size of the object, they appear to be the same. All right. So when you look at this, you'll find that the number of boxes here, what's going on? So the number of boxes here, you have 1, 2, 3, 4, 5. Even here you have 1, 2, 3, 4, 5. So you can say that the image is the same size as the object. So those are the characteristics that we have noted here. So we can say, 1, the image is real, inverted, same size as the object. But here you needed to just state 1. So if you stated this one, fine. Or if you stated this one, fine. Or this one, fine. Then C, they're saying, calculate the magnification of the lens. So magnification is given by this formula: image size divided by object size. Or there's another one which says magnification is equal to distance of the object from the lens divided by the distance of the object, or distance of the image from the lens divided by distance of the object from the lens. However, we are using this one. So when we look at the distance or size of the image here, we counted it to be 4 boxes. 1, 2, 3, 4, 5 boxes. Also for the image also we counted as 1, 2, 3, 4, 5. So they are of the same size. So say 5 units divided by 5 units, which will give us what? 1. So magnification is 1. Why? Because the image is the same size as the object. Then B7 reads, a step-up transformer increases the voltage of an AC supply from 110 volts to 220 volts. The primary coil dissipates a power of 1.1 kilowatt and the transformer has an efficiency of 100%. Then A, if the number of turns in the primary coil is 400, how many turns are in the secondary coil? So here you should understand how a transformer works. So a transformer consists of 2 coils. One on the left called the primary coil. The one which is on the left here is always called the primary coil. And then we have this another coil here called the secondary coil at the right. And these turns here, these coils are represented by NP, which stands for number of turns in the primary coil. And this NS stands for number of turns or coils in the secondary coil. Then the work of a transformer is either to step up voltage or step down voltage. For example, there is some voltage here, which also we read the voltage of the primary coil. And also there will be some current here, which we read IP, current of the primary coil. So when some current passes through the primary coil, it induces some magnetic fields in the what? In the iron core. This one we call it iron core. And there might be a question here where they may ask you, to explain how a transformer works, and then they may ask you why they use the soft iron core. The reason is because it is easy to magnetize and demagnetize. So this one, soft iron core. So when some alternating current or AC, this voltage here is supposed to be AC, which means it moves in a forward direction and backward direction. So when an alternating current flows here, it induces some also changing magnetic field in the soft iron core. And this changing magnetic field also induces some changing current in the secondary coil. That's the explanation you need to give if they ask you to explain how a transformer works. You say, if current, or you can just say, alternating current supplied in the primary coil creates an alternating magnetic field in the soft iron core. And this alternating magnetic field in the soft iron core induces alternating current in the secondary coil. That is it. All right? So that if you increase the words, you may even make some mistakes and ending up losing the marks. So now, yeah, that's how basically a transformer works. Now, we have two types of transformers. We have one called the step up, and the other one called the step down. So the step up transformer contains more coils in the secondary, and the step down transformer contains less coils in the secondary. But in this case, we have a step up transformer. So a step up transformer increases voltage in the secondary. So here, if we have to have voltage here at the secondary and current here, so here you should understand that you should know that here voltage in the primary, this voltage here in the primary is less than voltage in the secondary. However, it is vice versa. Current in the primary is greater than current in the what? In the secondary. That's how it's supposed to be. All right? So that when you multiply voltage in the primary times current in the primary, you get what we call the power in the primary. So again here you say voltage in the secondary times current in the secondary must give you power in the secondary. Now, for a transformer like this one where they are saying the primary coil dissipates a power of 1.1 kilowatts and the transformer has an efficiency of 100%. In a transformer which is efficiency, it means that power input is equal to power output, or power into the primary is equal to power into the secondary. It means power into the primary coil must be equal to power in the secondary coil. That's what it basically means here. So, but in reality, this does not happen because of some losses of electrical energy through heat in the soft iron core and some eddy current here, which causes reduction. So now basically this is what you need to know about a transformer. Nothing more, nothing less at your level. So now let's now go to the question. Question A says, if the number of turns in the primary coil is 400 here, how many turns are in the secondary coil? So you need to bring a transformer equation which says voltage in the primary coil divided by voltage in the secondary coil. So here voltage in the primary coil divided by voltage in the secondary coil is equal to number of turns here, number of turns NP in the primary coil divided by number of turns these in the secondary coil. Now the question says how many turns are in the secondary coil. So you make NS here the subject of the formula, number of turns in the secondary coil, which will give you number of turns in the secondary coil will be VS NP over VP. So you now substitute VS is voltage in the secondary. So they are saying a step-up transformer increases the voltage of an AC supply from. So from meaning from primary, which is 110 volts, to which means the voltage in the secondary 220 volts. So meaning voltage here is 220. Then NP number of turns. If the number of turns in the primary coil is 400, so here 400, then VP voltage in the primary, which is 110. So you substitute 220 times 400 divided by 110, you find that your answer will be 800 turns. So the number of turns in the secondary coil will be 800 turns, which is correct for a step-up transformer. In a step-up transformer, the number of turns in the secondary coil must be more than the number of turns in the primary coil. So in the primary coil, there are 400. So in the secondary coil, there are 800. This is how you notice whether your solving is correct or not. So now we come to B. B says how much current flows in the, so it says how much current flows in the primary coil. So they need current which is flowing in the primary coil, this current here, IP. So we know that current must be given by power. So we know that power in the primary coil must be given by voltage in the primary coil times current in the primary coil. All right? And when we make current, so how much current flows in the primary coil, we make IP, which is current in the primary coil, the subject of the formula. So we have power in the primary coil divided by voltage in the primary coil. So here, since we are told that the primary coil dissipates power of 1.1 kilowatt. So kilo here means 1000. So you'll say 1.1 times 1000, which will give you 1100. So meaning you have the power of 1100, where they are saying the primary coil dissipates a power of 1100. That's how you interpret this. Then here they are saying a step-up transformer increases the voltage of an AC supply from 110. So this is the voltage here in the primary. So you say 100 or you say 1100 here divided by 110. So basically that's what you have here. So you get your answer as 10 amps. So current in the primary will be 10 amps. So you put your answer there as 10 amps. Then B, you also calculate how much current flows in the secondary coil. So again here, what you are going to say here, since you have less information about power in the secondary coil, you are not given here. If you look here, you don't have power in the secondary coil. So you use the equation where you say power in the secondary coil must be equal to power in the primary coil. Why? Because the transformer has the efficiency of 100%, meaning the power that enters through the primary coil must be the power that goes out through the secondary coil. That's what basically what it means by 100% efficiency. Then since the question says how much current flows in the secondary coil, so you need to know the formula for finding power in the secondary coil. So power in the secondary coil is given by current in the secondary coil times voltage in the secondary coil. And this is the current they need. So what you are going to say is, since this P is equal to, PS is equal to PP, meaning here you can also put what? This. Or you can put this where? Here. Because this means this, and this means this. It means this also means that. So you say, this means that where there is PS, you put ISVS. Current in the secondary times voltage in the secondary is equal to power in the primary coil. Then you make IS the subject of the formula, where you have current in the secondary coil is equal to power in the primary coil over voltage in the secondary coil. So you substitute power in the primary coil was 1100 watts. Then voltage in the secondary coil is what? 220. So when you substitute and then you divide, you get your current in the secondary coil as 5 amps. So your current is 5 amps. Then you come to 8. 8 reads figure B8.1 below shows 2 pairs of 3.0 ohm resistors connected to a 6.0 volt battery. So you have this figure below showing 2 pairs of 6.0 ohm resistors connected to a 6.0 volt battery. So you have these pairs, this resistor here 3333. So now they are saying calculate the A resistor in the circuit between M and N. So you calculate the resistor between M and N. So they need the total resistor. So since this and this they are in series, I added 3 plus 3, I get 6 here, which you are seeing here. It's me who had to put it here. 3 also by plus 3, you get 6. Now you have this total here 6 and another 6 here. So these now will be in parallel. So for you to find the total resistor in parallel, you know that you need this formula which says 1 over RT, which is total resistant, is equal to 1 over R1, which will be this resistor, plus 1 over R2, this resistor here. Then you substitute 1 over RT is equal to 1 over 6 plus 1 over 6. Then you find the common denominator, which is 6. You say 6 into 6, 1. 1 times 1, 1. Then again 6 into 6, 1. 1 times 1, 1. Then you add. Say 1 over RT, 1 plus 1 is equal to 2 over 6. Then you cross multiply. You say this times that, you get RT. Then this times that, you get 6. Then you make RT the subject of the formula by dividing by 2 by 2. So you get here 3, because 2 into 2, they will cancel. 2 into 6, 3. So meaning total resistor here is what? 3 ohms. Then here B, they are saying you do what? Calculate current through the battery. So current is given by this formula. Voltage is equal to current times resistor. So this resistor must be the total resistor which we calculated, which is 3. So you make current the subject of the formula as voltage divided by R, and here if you look at this, you find that voltage is 6 and the total resistance we found was what? 3. So you say, okay, current now is equal to 6 divided by 3, which will mean that current will be equal to 2 amps. So you put your 2 amps where? There. Then you see, you say, it says you calculate, they are saying C, power developed in the battery. You calculate power developed in the battery. You know power is equal to current times voltage. And then you know that current is what? 2 and voltage is 6. So you say 2 times 6, you get what? 12 watts as your power. Don't forget to put the units. Then you go to another question, which is 9, which reads radioactive isotope is used to treat, or radioactive iodine is used to treat tumors of the thyroid gland. It decays by emitting beta particles and gamma radiation. Then the question says the beta emitting process is represented by the following equation. So you have iodine 13153. It decays to another element Xe with mass number A, then atomic number Z, plus a beta particle, this one. Then they're saying, A, what is the nucleon number of the new nucleus Xe formed? So nucleon number A is the mass number. So you need to know the general equation here, which guides decay or radiation by beta. So radiation by beta is guided by this general equation, which says if you have iodine 131 as mass number, then 53 here as the atomic number, then this Xe element will have the same mass number. However, its atomic number must increase by 1 plus then the what? The beta particle. So here, the mass numbers you can see, they must be the same. All right? So here the mass number must be the same. So it will be 131. Then here B, they're saying the half-life of iodine 131 is 8 days. B, the half-life of iodine 131 is 8 days. The total dose of iodine given to a patient initially emits 4 times 10 to the power 8 rays per second. The total dose of iodine given to a patient initially emits 4 times 10 to the power 8 rays per second. Then how many gamma rays does, or how many gamma rays does the total dose of iodine how many gamma rays does the total dose of iodine emit each second after 24 days? How many gamma rays does the total dose of iodine emit each second after 24 days? So now, here what they need is now to know the gamma rays which are emitted each second after 24 days. All right, so here what we should know is that total time is equal to number of half-life times half-life, or number of decays times half-life. Now here we are told the half-life of iodine 131 is 8 days. So here half-life is 8 days. Then here they are saying the total number of iodine given to a patient initially emits 4 times 10 to the power 80 rays per second. So this is the initial. Then how many gamma rays does the total dose of iodine emit each second after 24 days? So now, first of all, we need to know this number of decays which are there for 24 days. So 24 days is the total number. Then then we need to know how many decays are there of half-life in 24. So we'll make n the subject of the formula, T over half-life. Then we'll say 24 divided by 8, which will give us n. Then we'll use this formula, which says 2 to the power n is equal to original amount of the dose divided by the remaining dose. Then we will substitute now. Here we'll make this one the subject of the formula. So we'll just say the remaining dose is equal to the original dose divided by 2 to the power n. Then we'll substitute, we'll say A is equal to the original dose, which is 4 times 10 to the power 8 divided by 2 to the power 3, because n is equal to 3, which will give us remaining dose as 5 times 10 to the power 7, which will mean that number of gamma rays will be 5 times 10 to the power 7 rays per second. How many gamma rays does the total dose of iodine emit each second? So this is what is emitted in each second. All right. So the other way around, yeah, this is it. Then let's go to another question, section C. Section C consists of 20 marks, and here you answer any 2 questions from this section. Write your answers in the separate answer booklets provided. So here you answer from the separate answer booklets provided. So C1 reads, CA 2 reads, explain the term absolute temperature. Then B, state Charles' law. Then B says table C1.1 below displays results of temperature against volume of air at a constant pressure of 720 millimeters of mercury. Then copy and complete the table above. Plot a graph of volume in cubic centimeters against the temperature in Kelvin. Yeah. Then the last one says from the graph determine the volume of the air when the temperature was 77. So now here, the first question says, explain the term absolute zero temperature. So absolute zero temperature is the temperature at which the particles have zero potential energy and kinetic energy. The temperature at which the particles of a gas have zero vibration energy or potential energy and kinetic energy. This happens when air particles are cooled to a degree or to a temperature of 0 Kelvin. When they are cooled to a temperature of 0 Kelvin, it is assumed by scientists that at that temperature of 0 Kelvin, the particles of the gases have zero potential energy and kinetic energy. And that temperature at which the particles have zero potential energy and kinetic energy is called absolute zero temperature. So, A1, the answer is the temperature at which the particles of a substance have zero potential energy, vibration, and zero average kinetic energy. All right, or the temperature at which temperature in Kelvin is equal to 0. Then, 2, they are saying state Charles' law. So, I said Charles' law deals with the initials which I gave you. Beautiful, cute girls of 10 provinces. So, if you say Charles' law is for cute, then 10p. So it is at pressure should be constant. So Charles' law states that for a fixed mass of a gas at constant pressure, volume is directly proportional to temperature. That's what it states. So here we are going to say this one, TPV of BCG or BCG of TPV. So you are going to say for a fixed mass of a gas at constant pressure, the volume of the gas is directly proportional to the temperature of the gas. That is Charles' law. Or T is directly proportional to V is directly proportional to T, where you explain V is volume and T is temperature. Then B, they are saying the table C1.1 below displays results of temperature against volume of air at a constant pressure of 720 millimeters of mercury. Then they're saying copy and complete the table. So when you copy this table, here you are supposed to record what? Temperature in Kelvin. So you have to convert this temperature into Kelvin by adding 17 plus 273. This 28 plus 273, you get the total here. 39 plus 273, you put the total here. 60 plus 273, you put the total here. 80 plus 273, you put the total here. 100 plus 273, you put the total here. So you copy our table, then we add 17 plus 273. Using this formula here, you get 290. Then also 28 plus 273, you get 301. Then 39, you get 312. 60, you get 333. 80, you get 353. 100, you get 373. So you have completed the table. Then the other question here, 3.2 says plot a graph of volume, this volume here, against temperature in Kelvin. So it's now temperature, volume, temperature. So now here you have these values which you are going to plot here. Then what you are going to do now is to get volume against temperature is what you are going to plot. Then you bring your graph here. So you should make sure that your data here fits on the graph well. So here, if there's a volume against temperature, it means the volume here is on the vertical axis, or temperature on the horizontal axis. Right, so this one will be for temperature, and these are the values here. Looking at the data, temperature starts at 290. So I said if this is 290, so I had to put the difference of 10, 10, 10. So from 290 to 300, the difference is 10. From 300 to 310, the difference is 10. From 310 to 320, the difference is 10. So I said 290 because the graph seemed to be small for me to cut the data which I needed. So usually graphs begins from 0, but there's no harm to begin exactly at this point and also begin also exactly at that point, since these are not beginning from 0. So again, the vertical axis, again, I started from 7, since they are saying volume against the temperature. So I started at 7, then I said here I would just say 7, 8, 9, 10, the difference of 1, 1, 1. Then this is the volume in what? In centimeter cubed. So now I'll plot 290, 7.5. So 290, 7.5 is here. So this is 7.1, 0.2, 0.3, 0.4, 0.5, 0.6, 0.7, 0.8, 0.9, 8, 8.1, 0.2, 0.3, just like that. So this is 290, 7.5, the point there. Then I'll come to 301, 3. So this is the 3.0, 0.2, 0.4, 0.6, 0.8, 0.10. Now, since this is a 301, so this line is a 3.2, so 3.1 is on the middle. So 301, 9. So 301, 9 is somewhere here. So somewhere there, point there. Then 312, this is a 310. So this one will be 310.1, 312. So 312, 8.1. 8.1 is supposed to be somewhere here. Then we are supposed to have 333, 8.7. So 333, this is a 330, 332, 334. So 333 is in between here. So 333, 8.7. 8.7 is somewhere here. So there. Then 353, 353, this is a 52, 54, 53 is somewhere here, 9.1, which is somewhere here. Then 373, 373 is also somewhere here, what? 9.6, which is somewhere here. Yeah, somewhere here. Then I will draw a line. So when you look at these points here, they are not turning properly. So you can't move a straight line which can pass through each and every point. No. So what you are going just to do here is to move to make a best fit, to make just a line which can pass in some of the points and not in some of the other points like this. So it has passed through this point, and almost in this point, but it hasn't passed through this and that. So this is just the best fit line. So because of experimental errors, so the points could not come out properly as it were supposed to be. So in this case, you just draw a best fit. And since volume is directly proportional to temperature according to Charles' law, so it's supposed to give us a straight line. All right. So then, question C says, from the graph, determine the volume of the air when the temperature was 77. So here, what you are going to do is to add 277 plus 273, so that you change it to Kelvin. So which will give you a temperature of 350. So what you are going to do, since this one will give you a temperature of 350, meaning that 77 degrees Celsius plus 273, it will give you, excuse me, 350. So now, what they want is now, from the graph, determine the volume of the air when the temperature was 77. So you have converted this one into Kelvin. It has given you 250. So you come on 350, I mean, here, you draw a graph, this graph here by a red line, where it hits the line, you make a corner straight to the vertical axis. Where it ends, you discover that this is actually, no, this is 9.05, sorry. So it's supposed to be 9.05, because this is 9, 9.1, 0.2, 0.3, 0.4, 0.5, 0.6, 0.7, 0.8, 0.9, then it goes to 10. So meaning here it is 9.05. Yeah, so here it's supposed to be also not this one, but now the volume is supposed to be 9.05 centimeters. Alright, so let's go to the next question. C2 reads figure C2.1. Figure C2.1 below shows how a solar heater on a house roof is used to warm up water for a house. So this is a solar heater being used to warm up water in a tank. So when you study this figure, you find that you have some network of pipes there, and then you have glass cover this one, and then you have black panel there, then you have an insulator here, then you have a pump here. Okay, so then tank for storing heated water. Then the question are, why is the panel in the solar heater black? Then here B, why is there an insulating layer behind the panel? Then C, how does the water in the tank get heated? Then D, on average, each square meter of the solar panel receives 1,000 joules of energy from the sun every second. Using this information, calculate the power input in kilowatts of the panel if its surface area is 2 cubic meters. Then E, the solar heater in the diagram has an efficiency of 60 percent. It wastes 40% of the solar energy it receives. What area of panel would be needed to deliver heat at the same rate on average as a 3 kilowatt immersion heater? So to answer the first question, we are saying, why is the panel in the solar heater black? This panel here, all right, so that it can absorb some heat from the sun, So that's the answer. So here we said, to help the solar panel absorb infrared radiation or heat from the sun. Then B, they're saying, why is there an insulating layer behind the panel? This insulating layer, so it is to prevent the heat loss from the what? From the black panel. So to prevent the loss of heat from networks of pipes to the surrounding. Then see, how does the water in the tank get heated? This water. So the answer here is that when the water in the pipes is heated, it becomes less dense and rises to the water tank. Then the cooler or the colder water in the tank with more density sinks to replace it. This water is also heated and rises as well. The process continues until water in the system is uniformly heated. This process happens by the process called convection. All right. Then D says, on average, each square meter of the solar panel receives 100 joules of energy. So each square meter receives energy of what? 100 joules of energy from the sun every second. Using this information, calculate the power input in kilowatts of the panel if its surface area is 2 cubic meters. So in answering this question D, we said on average each square meter, so 1 square meter receives what? An average power. So it receives 100 or 1,000 joules of energy from the sun every second, so per second. So which means this is the power. So then they're saying, how much can what? Can 2 receive? So we say 1 cubic meter it's this energy. How about this? We'll cross multiply. So get as 2 joules per second. Then in watts, this is in watts. Then they said the answer should be in what? In kilowatts. So we divide by 1000 to change it in watts. So it becomes 2 kilowatts. Then E, the solar heater in the diagram, has an efficiency of 60%. What area of panel would be needed to deliver heat at the same rate on average as 3 kilowatt immersion heater? So to deliver, this should be now what the output. So we need now the input now. So what we are going to say is that efficiency is equal to power output divided by power input. Then we are going to find the power, output. It's the one we want. So power output is equal to efficiency times power input over 100. Then we know that power input, we were already told per area, per 1 cubic or per 1 square meter, per 1 square meter, it produces the input and power is 1000 watts. So now we want to know with this efficiency what will be the output. So the output after calculating is 600 watts. So now we are going to say that since 1 cubic meters is the one delivering 600 watts with this kind of efficiency, meaning 1 cubic or 1 square meter delivers some power output of 600 watts. Then we'll ask, how about this? What area will this now output deliver? So this one will be equal to 3000. So we'll say, how about 3000 watts? So we'll convert, because K means 1000 times 3000. What area is it going to be? So we'll cross and we'll multiply this times that 600x, this times that 3000 watts meter square, then we'll divide by that, or divide by that, so that we'll get our area as 5 square meter. So it means that 5 square meter is the one which is able to deliver the power of 3 kilowatts on average. And this actually makes sense, because here 1 delivers somewhere there, 2 delivers something like that, then 3 we expect it to go maybe to 3, then 4 we expect it, 3 to go to 6, somewhere like that. Now since there's this efficiency, so this amount of power must be generated by this area. All right. So lastly, let's go to C3. C3 reads, a radioactive substance B has a half-life of 4 years and undergoes radioactivity by giving out beta radiation. A, which of the containers, aluminium, thin plastic, or lead lined, would you use to safely store substance B? So since substance B is producing beta radiation, So you look for a substance which blocks what? Beta radiation properly. So aluminium is the best. This one lead will be the waste of resources because this one will be extreme measures now. Then thin plastic won't be at the safe side. To be at the safe side, we will use aluminium. Then copy and complete table C 3.1. So they are saying date 1st July 2008, mass of original radioactive substance left 8 kg. Then they want us to complete. So since this one has a half-life, meaning after 4 years, this one must decay. So from 2008 to 2012, this one must decay by half. So here we are going to have what? We are going to have 4. Then from 2012 to 2016, this one must decay, which means we are supposed to have in 2016 we are supposed to have 2 kg. Now here there's no 2016. Then from 2016 to 2020, this one also must decay by half, will remain with 1 kg. So here we are supposed to have 1 kg, here 4 kg. Okay, let's continue. Then here they're saying C, a giga counter was used to measure the activity in counts per second from a radioactive sample in the laboratory over a period of years. Over this period, the background radiation was regularly measured at 4 counts per second. So there was background radiation. So time in years 0, 1, 2, 3, 4, 5, 6. All right, then they are saying recorded activity in counts was this. Then the activity due to the sample alone, this. So they had to subtract this background radiation to get this. So 124 minus, 124, yes, minus 4. They got what? 120. Because whenever you are doing an experiment to do with the measuring radioactivity, what you should know is that there is always radiation in the background which comes from cosmic rays in the universe or outer space. Also some background radiation from rocks and also concrete walls, and some stresses of some elements in the environment just also produce radiation which we call background radiation, which we define as radiation detected in the absence of a radioactive substance or sample. So when you're doing an experiment, there's a recording of background, so that you would subtract that background radiation from the actual count rate recorded from the radioactive source to know now the actual radioactive alone produced by the radioactive material. So here recorded activity counts per minute was 24, 124, 80, 52, 34, 23, 16, 12. So here they said 124 minus 4, they go to 20. So you do the same here. This minus 4 you put here, minus 4 you put this, 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 minus 4, 8 they had to put. Then say copy and complete the table on the activity of the sample alone. Then explain what is meant by background. Then plot a graph of the values for activity due to the sample alone against the time. Then using your graph determine the half-life of the substance. So we'll come back. Which of the containers? I said aluminium. So here, aluminium. Then here, copy and complete the table. Here we said we are going to have 4. Here we are going to have 1. Then here they're saying copy and complete the table on the activity of the sample alone. So I said you start subtracting. So here 120, here subtract, you get 76, 48, 30, 19, 12. So we are subtracting this by 4, you get this by 4, this by 4, this by 4, this by 4, this. All right. Then explain what is meant by background radiation. So this is the radiation recorded in the absence of a radioactive sample. Then here they are saying plot a graph of the values for activity due to the sample alone against the time. So now we'll plot. So get these are our values, this times time against time. So bring our graph here. This is our graph. So since they are saying time is always on the horizontal axis, then activity on the vertical. So activity against time. So activity vertical, time always horizontal. So time, activity 0. Excuse me. So you make sure that you put this data to fit properly here. So time will begin nicely 0, 1, 2 up to 6. So say 1, 2, 3, 4, 5, 6, 7. Then here now we'll be careful to make sure that our values here fit. So what did we say? We said we began at 20, 40, 60, 80, 100, 120 for these values of ours to fit. Then this box represented what? 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. So it represented 2 units. Each small box represented 2 units. So it is 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. That's how I managed to allocate these values here. So we'll say 0, 120, 120 somewhere there, 0, 120. We'll put a point there. Then we'll say 1,76, 1,76. So this is 60, 62, 64, 66, 68, 70, then 72, 74, 76 there. Then this one will be 2,48. So this is 2,48. This is 40, 42, 44, 46, 48 somewhere here. Then this is 3,30, 3,33. This is 20, 22, 24, 26, 28, 30 here. Then this is 4,19. So this is 4, 2, 4, 6, 8, 10, 12, 14, 16, 18, 19, in between there. Yeah, somewhere there. Then 5,12, 5,12, say 2, 4, 6, 8, 10, 12, somewhere there. And then this one is 6,8, 8, which will be 2, 4, 6, 8, somewhere there. Then we'll draw a smooth curve like that. All right, this is the graph they needed. Then lastly, they're saying, using your graph, determine the half-life of the substance. So what we are going to do is to divide this amount by half activity, which will give us 60, to draw a line from here. When it touches the curve, we go down and read the time. So since this is 1, 2, or 1.2.4.6, 1.2.4.6.8, then 2. So this is 1.2, 1.4. Here in the between it is 1.5. So now the half-life is 1.5 years, since time is in years. So guys, at this point we have come to the end of the video. We have come a long way, guys. Thank you for watching, and please guys, if you haven't yet subscribed, consider subscribing, because in my next video that I'm going to produce tomorrow, it will actually contain some ideas on how to answer questions on polymers, because I've made a very good video about polymers, which will make you understand especially macro molecules and the polyesters and polyamides and the natural molecules such as proteins and also carbohydrates and also fats. All right guys, thank you for watching. See you in the next video. Bye for now and peace.